Poonam Sharma, your science teacher, welcome you all again. Another session of very interesting chapter, atoms and molecules. So children, as I told you, this is extremely important chapter of chemistry, and we have discussed chemical formulas in previous class, and I've given few questions as a homework to you. So I hope you have done those questions. So in this class, I'll discuss those questions as well, and then I'll discuss the other topics. So first, I'll recapitulate chemical formula, which I have already elaborated in previous class. So as I told you, when you're writing chemical formula, like if I'll say water, so you immediately write formula of water, this H2O. But how these formulas are created? How can we write these chemical formula? So there are certain rules which I have already discussed with you in previous class. So in today's class, I'll take more examples of writing chemical formulas. Calcium hydroxide I have already discussed with you. And when you are writing chemical formula, this table should be learned. Learn this table, otherwise you'll not be able to write any formula. So now let's take an example of aluminium oxide. So aluminium oxide, the name is given in the question. Write down the chemical formula of aluminium oxide. How will you write? So aluminium oxide, first step is, what is the first step? Write in the comment box. Yesterday I discussed all the rules, all these steps, and simultaneously solve these questions with me. So first step is write the symbols of the elements involved in that chemical formula. So if aluminium oxide is written, so it means aluminium and oxygen, two elements are involved. So here I have written aluminium and oxygen. Now look at the table. Aluminium is here, and what charge does it have? It has +3. So I'll write +3 here. It's a valency of this aluminium. And oxygen, its valency is 2. So I've written 2 here. And then crisscross these valencies and you'll get this answer, Al2O3. And when we are writing chemical formula, I've told you earlier also that don't write charges. So when you are representing any chemical compound with its formula, no need to write charges, because these charges are nullified. So we'll always write formulas like this only. No need to mention any kind of charges. Now there are certain more examples. Sodium carbonate. It means sodium and carbonate. Two are involved. Sodium. Where is sodium written? Here. Sodium is here. And carbonate. Look at this. Carbonate. Okay. So this is carbonate. So here, sodium carbonate. So I have written sodium and carbonate, their formula. And then I'll write their valency. Sodium valency is plus, it means 1. And carbonate valency is 2. Look at here, it is -2. So you'll write like this. Here, you can write, and by crisscross, we'll get this answer, Na2CO3. Now look at another example, aluminium sulfate. Aluminium, Al, sulfate is SO4. So sulfate, where is sulfate written? Here it is sulfate. So SO4, you can see here this. Don't consider these subscripts. These are not valencies. Valencies are always written at the top here. So and sulfate is -2, aluminium is +3. After crisscrossing, these are polyatomic. And if you remember that rule, if polyatomic ions are present, then we always write in bracket. And then you'll ask, ma'am, why we have not written this polyatomic in bracket? You can write, but it is 1, so no need to write in bracket. If it is more than 1, then you have to write this polyatomic ion in bracket and then write out this valency here. So in this manner, we'll write polyatomic ions. These are the rules when you are writing chemical formulas. Always remember each and every rule. Then we have calcium hydroxide. Calcium, look at this calcium, it's +2. And hydroxide, where it is hydroxide, it is 1. So after crisscrossing, you can write CaOH2. Again, it is polyatomic because it contains oxygen and hydrogen. Simple. Then next is ammonium sulfate. Ammonium is NH4 plus, it means 1. SO4 sulfate, it has 2. So after crisscrossing, we'll get NH42. Will not write like this. No, don't write down like this. Always write polyatomic ions in bracket. And if it is 1, so no need to make any bracket. It is understood. But if it is more than 1, like here, so that's why I use this bracket here and SO4. Then we have magnesium hydroxide. Magnesium. Where is magnesium? Here it is magnesium. It has 2. And hydroxide. Again, 1. After crisscrossing, we'll get NgOH2. So in this manner, question can come in exam. They'll give you name of the chemical compounds and then you have to write their formula. So these are the steps and how will you write the chemical formula. So I hope this is clear to you, and do practice all these questions on your own so that all the doubt will be more clear. Then this is the question. Write down chemical formula of sodium sulfide, magnesium hydroxide, calcium bicarbonate, sodium hydrogen carbonate, potassium nitrate, ammonium sulfate, and calcium chloride. So first, sodium sulfide. Now tell me, how will you write this chemical formula of sodium sulfide? So first, sodium sulfide, it means Na. First step is write down the this element. Sulfide, just look at the sulfide, where it is sulfide. It is S2 minus. So I'll write here S2 minus. Then it has 1 valency, it has -2 valency, no need to write here. Then after crisscross, we'll get Na2S. That is sodium sulfide. I think it's quite easy now. Now next is magnesium hydroxide. Magnesium hydroxide. Now tell me which elements are involved into it. Magnesium and hydroxide. Again, hydroxide, it means it has hydrogen and oxygen. Hydro means hydrogen and oxide means oxygen. Again, it is a polyatomic. So I'll write OH here. Okay. Now this is magnesium. It is 2 plus and hydroxide is as 1. So I'll write their valency as 2 and it has 1. Then after writing this, I'll just crisscross their valencies and we'll get this answer. Again, it's a polyatomic. That's why I've written in bracket. I hope that this is very simple now. Then calcium bicarbonate. Calcium bicarbonate. It means, see here, it is carbonate. So I'll write bicarbonate. It is CO3 minus. Okay. Then Ca, calcium is Ca, calcium 2 plus. I'll write 2 plus A. And then it is carbonate, not bicarbonate, it's carbonate. Then CO3 is 2 minus. Now look at this example. It is very important. See, calcium carbonate. So calcium is 2 minus, carbonate is again 2 plus, carbonate is 2 minus and calcium is 2 plus. So after crisscrossing, now one more rule is there. When numbers are same, so we'll divide it by the common number. So if we have 2 and 2 here, so we can easily cut 2 with this 2. Then simply we can write CaCO3. Understood? Again, Look at this example again. Ca, it's carbonate, not bicarbonate. CO3, and Ca is calcium, which is 2 plus and it is 2 minus. Again, after crisscrossing it, and if same number are there, so this is another rule. If the same number is there, divide both the numbers by the common number, and we can easily cut 2 with 2 and we'll simply write CaCO3. Fine. Then sodium hydrogen carbonate. Sodium hydrogen carbonate. Sodium hydrogen carbonate. Sodium is 1 plus, hydrogen carbonate is 1 minus. Again, they are same, so we simply write NaHCO3. I think this is very simple now. Then we have potassium nitrate. Now, simultaneously write down answers. If you know the answer of these chemical formula, write down in the comment box. Potassium nitrate. Potassium represented by symbol K, and nitrate. Where is nitrate? Here it is nitrate. So I'll write NO3 minus. Okay. And this potassium has +1 and this has -1. Again, crisscrossing, no need to write this charge here. So I'll write KNO3. As simple as that. I think now this writing chemical formulas are very easy for you. And then we have ammonium sulfate. Ammonium sulfate, NH4, ammonium. And sulfate is SO4. Look at their charges. Ammonium has +1 and sulfate has -2. Then we'll crisscross. Now look here. This is polyatomic. This is also polyatomic. So I'll write NH4 in bracket. Then I'll write 2 and SO4. There is no need to write down this polyatomic in bracket because here is 1 only. Okay. Then we have calcium chloride. Calcium chloride. Calcium +2 and chloride -1. Again, by crisscrossing, we'll get CaCl2. Easy. So I hope this chemical formula concept is clear to you. We have done ample of examples and you can practice yourself. Then next is molecular mass. What is molecular mass? The molecular mass is the mass of the molecules contained in a compound. Like atomic mass we have done. Atomic mass means number of atoms present in an element. But when we are talking about compounds, compounds are formed by the molecule. So number of molecules which are present in a compound is known as its molecular mass. And how can we write molecular mass? Look here. For this you need to learn this table. You should know atomic number and the atomic mass number. So you have to learn this table. For example, and it is represented by symbol U, or we call it unified mass or AMU. Again same, AMU or U. Now how will we write molecular mass? Let's look at the example of water. The formula of water is H2O. Now it contains 2 hydrogen and 1 oxygen. Structure is somewhat like this. Okay, it contains 2 hydrogen and 1 oxygen. So it is 2 hydrogen. It means 2 multiply, and what is the atomic mass? 1 plus, and hydrogen is 1 here. So I'll write 1 multiply by its atomic mass. What is the atomic mass of oxygen? It is 16. So I'll write 16 here. And if I'll solve it, 2 plus then 16 is equal to 18 U, or 18 AMU is the molecular mass of water. So let's do a few more examples. So first I'll show you atomic masses of elements, and you have to learn atomic mass till atomic number 20. So you need to learn this table, their symbols, their atomic number and atomic masses. Just learn till 20 only in your syllabus till here. It's sufficient if you learn till 20, no need to learn beyond that, just for 9th standard. So hydrogen, 1 atomic mass, helium 4, lithium 7, beryllium 9, boron 11, carbon 12, nitrogen 14, oxygen 16, fluorine 19, neon 20, sodium 23, magnesium 24, aluminium 27, and then silicon 28, phosphorus 31, sulfur 32, chlorine 35.5, argon 40, potassium 39, and calcium 40. So these are the atomic mass number or atomic masses of these elements. And look here, argon and calcium, they both have atomic mass 40, and these kind of elements are known as isobars. We'll discuss about isobars in next chapter in detail. So these are the atomic masses of these elements. Then we have, now let's move on. Just a second. Now we'll do molecular mass, how to find molecular masses. So here are certain examples. How can you calculate molecular mass of the following compounds which are mentioned here? First is H2CO3. Now you need to calculate the molecular mass of this compound. And how will you find out? Look here. Hydrogen 2. First, look at the elements which are present in this formula. It has hydrogen, carbon, and oxygen. So hydrogen is 2 in number, so I've written 2 here, and its atomic mass is 1. So multiply this atomic mass with 1. Then plus, how many carbon are present? 1. And what is the atomic mass of carbon? It is 12. That's why I'm saying learn this table. Then only you'll be able to write down the molecular masses. Then for carbon, this in this way I'll write. Then again put the sign of plus. Then oxygen 3 multiply and by this atomic mass, which is 16. Then solve it. 2 ones are 2, then plus 12, then plus 48, and is equal to 62 U. So this is the molecular mass of this compound. Then we have ethanol, C2H5OH. You need to calculate the molecular mass of this compound. Again, same procedure. Carbon 2 in number. Look at this atomic mass, which is 12. Then hydrogen 5, atomic mass is 1, plus again oxygen is 1 multiplied by 16, then plus, and if hydrogen comes 2 times, 1 time, so you have to write same element separately. Like here hydrogen comes 2 times, but you need to write both the hydrogen separately. The way I have written 1 multiply by 1. So here this hydrogen and this hydrogen. Now solve it. 24 plus 5 plus 16 plus 1, and answer is 46 U. Now we have magnesium sulfate. I hope this is clear how you calculate molecular mass of these following compounds. Then we have magnesium sulfate. Magnesium is 1. Look at its molecular mass, atomic mass, which is 24. So I'll write 1 into 24. plus, this is sulfur. Sulfur is 1 in number, and look at its atomic mass, which is 32, plus 4 multiplied by 16, and then solve it. 24 plus 32 plus 64, simple addition, and then you will get answer 120U. So I hope this is clear how you will write molecular mass or how you calculate molecular mass. And unit, you will write U, which is unified mass, or in place of U, you can write AMU, atomic mass. Okay. Now these are another examples of molecular mass of hydrogen. Same process, 2 into 1 plus 1 into 16, 18U. Molecular mass of carbon dioxide gas, 1 into 12 plus 2 into 16. So 12 and 32 is equal to 44. Whether it is a gas or anything, any other compound or any solid substance, the formula for calculating molecular mass is same in all the cases. Now we have methane. So 1 into C plus 4 into H, or you can write like similar directly this step you can write, then 12 plus 4 is equal to 16. So this is how you calculate molecular mass of the following compounds. Now next is formula unit mass. Although molecular mass and formula unit mass, they both are same. The way of calculating formula mass and molecular mass is same. But the difference between these two is, this formula unit mass is for the ionic compound basically. And we write this formula unit mass on the basis of the formula of a compound. For example, if we take an example of NaCl, and if we look at the structure of NaCl, it is crystalline. It is crystal form. So it is a combination of Na and Cl. So we'll not write like this that these much sodium ions are present, or these many chlorine ions are present. So we'll not write like this. We always write formula NaCl. So we need to calculate formula unit mass. So with the help of this formula only. And the process or the method for writing formula unit mass is similar to that of the molecular mass. Here you can see NaCl, 1 into 23. So it hardly matters whether it is positive or negative. Just look at the atomic mass, the mass number of these elements. So it is sodium. We'll take it as sodium only. Sodium, it is 23 here. So I've written 23 plus 1 into 35.5 chlorine. If it is given in the charges form, in the ions form, so don't consider these charges. Just write down their mass number only. Same method. The way you were calculating molecular mass, same method you will apply for calculating formula unit mass also. And unit is also same. And the answer is 58.5 U. So don't get confused if the question comes right on formula unit mass or molecular mass. Same method you need to follow. Now formula unit mass of CaHCO3, calcium hydrogen carbonate. Now how will you write this? First look at the elements which are involved into it: calcium, hydrogen, carbon and oxygen. Each and every element is important. Don't miss any element. If you miss any of the element in the formula, your answer will be wrong. So don't miss any element. So that is the most important step. So mass of one atom, it's 1. So mass of one atom of calcium, mass of 2 atoms of hydrogen, because this is applicable for entire this one, hydrogen carbonate. So it means it has mass of 2 atoms of hydrogen and mass of 2 atoms of carbon, mass of 6 atoms of oxygen. How this 6 comes here? Because it is already 3, so we'll multiply these two numbers and it is 6 here. Here hydrogen is 1 and carbon is 1. So that's why only 2 atoms of hydrogen and carbon are present there. Now write down their atomic masses. So 1 multiplied by calcium is 40, as you can see here, 40, and then hydrogen 1, then carbon 12, and oxygen 16. So simply multiply these numbers, the number of atoms with their atomic masses, and we'll get this answer: 40 plus 2 plus 24 plus 96, and finally we'll get 162 AMU. That is a formula unit mass of calcium hydrogen carbonate. Okay, so this is how you'll calculate the formula unit mass. Now, very important concept of this chapter is mole concept. Why there's a need of this mole concept? Why it is required? Because atoms or molecules which are present in element, they are quite so small. So we cannot measure their masses as such. So we can measure them in by some particular unit, and that is known as mole. So if when we measure like distance in meters, kilometers, so we'll measure the number of atoms or molecules or ions, or you can say any charged particles. Okay, so when 1 mole is basically the quantity in number having an equal mass to its atomic or molecular mass in grams. So why this mole is required? The usage of this mole is it helps us to measure the number of atoms, molecules, or charged particles, whether they are cations or anions present in that particular element. We can be measured with the help of this mole. And 1 mole is equal to 6.022 into 10 raised to power 23 Avogadro's number. Avogadro's number, which is represented by Na or NO. What is this Avogadro's number? See, when we measure anything, like we are saying 1 pair of shoes, so it has 2 shoes. If we are saying 1 dozen of bananas, so it has 12 bananas in it. So if we are saying 1 mole, so 1 mole is equal to 6.022 into 10 raised to power 23 Avogadro's number. So these two are equivalent. And molar mass is equal to mass of 1 mole. It is always expressed in grams. Let's don't get confused. Let's see how we can express in grams. Or if we are representing mass of 1 mole, we can write in grams also. It means that in that case we'll write gram atomic mass. Fine. So if we are writing mass of 1 mole, we can also represent in grams, or in place of this 1 gram, 1 mole, or we can write 12. If we are writing 12 mole, it means 12 gram. So they both are equivalent. So we can represent this mole in grams as well. And in that case, we'll write this atomic mass as gram atomic mass. Now example is 1U, means unified mass of hydrogen has 1 atom of hydrogen. Or we can write 1 gram of hydrogen or 1 mole of hydrogen. So both are same thing. So we can write 1 mole of hydrogen, or if we'll represent in gram atomic mass, we can write 1 gram of hydrogen, and they both are always equal to 6.022 into 10 raised to power 23 atoms of hydrogen, and this also equivalent to this one. So if in a question it is given this much gram of any element, suppose calcium is present, calculate its molar mass. So how will you calculate? Just multiply that given gram by this Avogadro's number and simply you will get the answer. For example, like 2H2, we have this water, 2H plus O, which is a combination of 2 hydrogen of water, sorry, 2 atoms of hydrogen and 1 of oxygen. Now, 2 molecules of hydrogen when combined with 1 molecule of oxygen, it forms 2 molecules of water. Or we can say that 4U of hydrogen molecules combined with 32U of oxygen molecules to form 36U of water molecules. What does it mean? If you'll write this, 2 into 1 plus 1 into 16, or it forms 4 into 1 plus 1 into 16. So this is 4 plus 16 is equal to, so we have this 4 plus 16, sorry, here we have written this. So we can write like this, like 4U of hydrogen molecules, like 4U of hydrogen molecules combined with 32U of oxygen, and then to form 36U of water molecule. So this 2 is applicable to this hydrogen. Now in this way, it is very easy for us to calculate the molecular mass. Now what is the relationship between mole, Avogadro number and mass? As I told you, if you are writing 1 mole of carbon atom, so it is equivalent to 6.02 into 10 raised to power 22 atoms of carbon, or simply you can write 12 gram of carbon atoms. So 1 C12, which is equivalent to 6.02 gram, or simply we can write 12 gram. So they both are equivalent. And if we are saying 1 mole of hydrogen atom, it is equivalent to 1 gram of hydrogen, or it is equivalent to Avogadro's number. So they both are equal. Similarly, 1 mole of any particle, that can be any cation, anion, anything. So again, it is relative mass of particle in grams. So we can represent mole by gram also. Instead of writing mole, we can write gram. Suppose 20 mole of calcium, or in place of this we can write 20 gram of calcium, and they both are equivalent to Avogadro's number, which is 6.022 into 10 raised to power 23. Fine. Then 1 mole of molecules. So whether it is a case of atoms, molecules, ions, whether they are cation, anion, any charged particles, this Avogadro's number is always same for all these atoms, molecules and charged particles. So 1 mole of molecules is equal to molecular mass in grams, or we can write it is equal to 6.022 into 10 raised to power 23 Avogadro's number. Let's take an example. We are talking about molecular mass. It means we are talking about molecules. So if we are saying 64 gram of NaCl, okay, it has ions, it contains charges Na plus and Cl minus. So if the question in the question 64 gram of NaCl, so it means, or 64 molecules of NaCl. Again, if for both, they are equivalent to Avogadro's number. Fine. So in place of these molecules, we can write in grams. And they both are always equal to 6.022 into 10 raised to power 23, which is Avogadro's number. So mass of one molecule of a substance is always equal to its relative atomic mass, which I have just already explained to you. And few examples are there. Atomic mass of hydrogen is 1 U, and gram atomic mass is 1 gram. So 1 U hydrogen has only one atom of hydrogen. So it is easy for us to calculate number of atoms in hydrogen element. Okay, so with the help of this mole concept, it is very easy for us. Otherwise, we cannot measure these atoms because they are so small. And if 1 gram hydrogen has 1 mole, so it means it has these number of atoms, which is raised to power 23. So Avogadro's number, which is 6.022 into 10 raised to power 23, is always equal to 1 gram and 1 mole. Fine. Then similarly, another example for oxygen is if 16U oxygen has only one atom of oxygen. So it means it has 1 mole atom, which is equivalent to again the same Avogadro's number. So this Avogadro's number is always equivalent for atom, one molecule, one charge particle. One charge particle. Or this particle can be cation, anion, or anything. Okay. And it is always equals to 6.022 into 10 raised to power 23. So now till here, I think it's clear. And how can we calculate this? For on the basis of this, lots of numericals are there. So I'll discuss those numericals along with some important questions, and I'll elaborate this in next class. So till then, revise this concept, whatever I taught you today. Just go through it and try to find out chemical formula and molecular formula of few examples. So this is the mole concept, and I'll elaborate more mole concept in next class also along with some examples. So till then, take care and goodbye. Just revise this mole concept. Just ignore this part. So this is how Avogadro's number is very important, which is represented by N, A or N